Hi, everyone. Welcome to the Marvelous Mushrooms Workshop. This is Mara from GreenThumb. I'm so excited that we're able to offer this as a virtual webinar. So thank you so much to Gil and the members of Smiling Hogshead Ranch for pulling together what is usually a 3-hour in-person, hands-on workshop to be virtual and half the time. We really appreciate you. For everyone who's tuning in, we welcome you. Thank you so much for joining virtually. We're super excited. We ask that everyone stay muted so that we can hear our facilitator speak. I will be keeping everyone muted as much as I can, but it's good to have everyone's help since we have over 100 people tuning in. Also tuning in today, we have Laura from GrowNYC and Yolanda from Cornell Cooperative Extension. So in a second, I'm going to let them say hi. And we're thrilled to be here. And thank you to my colleague Claudia, who is our intrepid filmmaker today. So Laura, I think I'm going to pass the video to you. There are a couple NYC DOEs on here. So I'm gonna unmute one of them and hope that that's you.
Okay, well, I unmuted myself if everyone can hear me now.
Yes.
So, okay, great. Yes, so I'm Laura Casaregola. I'm with GrowNYC School Gardens. So we help build and maintain school gardens in public schools in all 5 boroughs of New York City. I just wanted to say thank you so much to GreenThumb and the presenters for putting on this workshop and letting us all tag in on it. I see quite a few DOE email addresses in the participants view. So just wanted to say hello to all the school gardeners out there. And if you have any questions pertaining to school gardens, feel free to reach me in this chat here or follow up with an email anytime. There's 2 things I wanted to let everyone know about as well, which could be useful to school gardeners and community gardeners here today. We have a new distance learning page that has a lot of great resources, activities, videos, recipes, gardening tips, and things like that. And it's GrowNYCdistancelearning.org. I'll throw that link in the chat. We also have an upcoming workshop series with the GrowNYC education programs, and it's a beginner gardener intensive during the 2nd week of June. And so we're gonna each day from Monday to Friday do a 30-minute session on a gardening topic, such as seed starting, garden design, compost at home, things like that. So that's the beginner gardener intensive. I'll also throw the link to sign up for that workshop series. And then one last thing is I saw someone in the chat did ask about what's the protocol surrounding community and school gardening. Right now during coronavirus, I'll let GreenThumb elaborate more on the community garden protocol because they do have a separate protocol. Right now, the best we know for like New York City public schools is you do have to, there's a protocol that involves your principal. So everyone should just reach out to their principal on a case-by-case basis. There's a new way that you can fill out a request form to access your school garden, and you have to fill that out and get it approved 48 hours in advance in order to have access to your garden. And then on top of that, there's a lot of like social distance protocols. So if you have any more in-depth questions about that, feel free to send me an email and I can send you what that form looks like and how to get in touch with your principal so that you can try to get access to your school garden and do it in as safe a way as possible. So thanks again so much for having us. I'll turn it back over.
Thank you, Laura. That was all really helpful. I put the link to GreenThumb's COVID-19 protocol in the chat so everyone can head over there. There's another link with best practices that I'll share in just a minute. So Yolanda, I am going to pass the mic to you now.
Great. I am going to try to share my screen. I just created, looks like I don't have.
Okay, I will give you presenter role.
Okay, I did before, something must have happened, I'm not sure. Okay, excellent. Thank you. So hi everyone, my name is Mara. I'm sorry, this is just Mara.
It's fine, you can be Mara.
Thank you so much. Sorry. So I'm with Cornell Cooperative Extension, and I am an urban agriculture specialist based out in Fort Greene, Brooklyn. Our office we share with USDA and Ag and Markets. And right now, one of the major projects that we're working on is something called the Community Mushroom Educator Program. And this is a training program that aims to build a cohort of around 60 different educators throughout the Northeast, both in urban and rural centers. Originally, we had scheduled 3 different in-person trainings this year, so we've kind of switched to having virtual distance learning opportunities. So it was a hybrid model where we were doing like online and we were going to have in person, but now we're kind of doing all online through a platform called Teachable. And this program is actually funded through SARE, the PDP Professional Development Program. I'm not sure how to get rid of the annotation. Okay, let me try this. I'm not sure. There was a request to annotate. I'm not sure how to request that.
I will try to figure that out. If you move your mouse, I think up to the top of the screen.
Mm-hmm. Okay, let me try to get rid of that.
Okay.
Everybody for your patience. So where can you find out more information about the CME Community Mushroom Educator Training? That's what we're calling it in short, CME. If you go to the Cornell Small Farms website under projects and then click on specialty mushrooms, then click on Community Mushroom Educator Training. We have an informational video as well as just a detailed description of what the training entails. And the applications are closed this year. We've already accepted the cohort, but we'll let you know about a future program if you sign up for our grower email list. So this is the listserv, and it'll take you to this form that you'll fill out, and then you just enter your email and you can subscribe. Through that listserv, we try to connect you with the latest events, any information that is most relevant, or if we have articles and things like that. And then also on our website, I just wanted to point out, if you go to outdoor production, you'll find information. I'm sure Gil might mention it at some point, but wine cap mushrooms work really well in urban settings, especially if you have clean soil and you're growing alongside a raised bed. I'll just show you a few examples of that. So this is actually of another farm in Long Island City. It's called Hellgate Farm, and they're growing on a rooftop. So growing alongside the garlic is just an example of what the wine cap mushrooms look like. And I'll follow up with Mara with a handout that will kind of explain this step-by-step process. But essentially, I just wanted to highlight this mushroom just because it's so friendly to different urban gardens. You can grow it alongside existing vegetables and get quite, if you also inoculate throughout the season, you can have a succession of wine caps throughout the summer and the spring. Just a note, so that's what the harvest actually looks like. They grow well in garden sun, and they grow best in part sun. They can grow as little as 2 to 6 months. So it really doesn't take that long. Now is a good time to inoculate your bed. And one of the best ways to inoculate is kind of to follow this lasagna layering method. So using wood chips that you may already be using for your garden pathways, you can layer that with, let's say, the spawn and then some straw, or you can use cardboard or wood shavings, whatever you kind of have handy. And then beyond how-to videos on our website, you can also find a link to our YouTube channel. So last year we had a webinar series where we basically brought in different speakers like Trad Cotter and Bill Padilla-Brown and talked about mycopesticides and food safety and business planning and a wide range of different topics. So that's all recorded. And if you wanted to take a look, they're all on our YouTube website. And then I just wanted to highlight some additional opportunities for learning. So there is the New York Mycological Society. And previously in other years where we didn't have this crisis, they led great foraging tours. So this was actually a photo of a tour in a park in the Bronx. And now they've kind of switched over to virtual learning. So they're offering a webinar series. They had one recently on morels. This is kind of the season for morels. So they talked about how to spot a fake morel and kind of different recipes that you can use them in, their seasonality and habitat and so forth. And then another great resource are Facebook groups. So two in particular are Mushroom Growing Mentors. That's the name of one Facebook group, and Mushroom Growing. And it's basically like a peer-to-peer network. So you can ask questions. Maybe you want to learn how to create your own grow room in your apartment. You can see different models and examples of how others have done that. And this is our Urban Ag page. We often post upcoming events, and we'll continue to post online virtual events as well. And my email is here also. So if you have any questions, again, I'll be following up with a PDF of this slideshow and then maybe two other PDFs, one on the fact sheet about wine caps and then the other one about general considerations of growing. Just making sure that you're growing in clean soil and that you're not growing directly in the ground, but in raised beds. That's a really important concept. So that's all I had. Just wanted to share that. Thanks a lot.
Thank you, Yolanda. It was great to hear all about the amazing programming that Cornell Cooperative Extension is doing. We really appreciate you and are so excited also to work with you this summer on the What's Wrong with My Veggies series. It's going to be great. I will send out information about that in a follow-up email to everyone who's on this call. But we're looking forward to doing a Q&A session monthly with our expert friends at Cornell Cooperative Extension. So thank you, Yolanda, and thank you, Laura. So without further ado, Gil, I am about to give you the floor. So Gil Lopez is an environmental educator, a landscape consultant, and an activist who is on the front lines of the urban compost issue. He worked for the New York City Compost Project before being laid off due to COVID-19 budget cuts and has been a community composter for over a decade. Gil is the co-founder and president of Smiling Hogshead Ranch and is actively reclaiming the commons and cultivating community. Thank you so much, Gil. We are so thrilled to be with you today virtually. And yeah, the floor is yours. I might have to unmute you.
Okay.
All right, there
Can
you
everybody
go.
hear me now?
Yep, we're good.
Okay, cool. So thanks everybody for joining. I really love teaching this workshop. This is like the 4th or 5th year that I'm doing this with GreenThumb. I also do this at other venues. This is the first time I'm teaching this at a distance or online. And we're going to go through a lot of information really quickly because this is usually, like Mara said, a 3-hour workshop, and me and my collaborator Jan Nunn usually separate into 2 or even 3 different groups and go over a lot of material. So I apologize ahead of time. We're going to go over stuff so quickly, it's going to be hard to retain things. We will have a Q&A. There's several different techniques that I want to talk about. I'm really going to focus in on the milk crate or the kind of indoor growing, but also talking about how to do this in your gardens, because I realize that this is geared for gardeners who want to do this in their gardens, but right now a lot of people are confined to their homes. So there's just a lot of different ways to do this. I'm going to put this away, and I'm also going to I have Claudia over there filming. I have one other garden member who's going to be helping kind of like further in the background, but I'm going to remove my mask right now so that I can talk to you a little bit more comfortably and you can see my lips moving, hopefully. So we're going to go through a lot of different information. Usually we talk about and do some inoculation through thermal processing and homogenous or decontamination of our mulch, which is we're not going to do today, but just to show you guys, we have a this is just a propane burner. We don't have a tank attached to it right now, but that makes a big flame. I usually use a 55-gallon drum, but just to show you kind of what we're doing here, we would fill this up with basically wood chips and water, and then we would boil that. We would bring it up to temperature of boiling, and we would let that go for about an hour and a half to 2 hours to kill off any pathogens, any other fungi that or spore or bacteria, mold, anything that's living on that mulch. Because what we want to do is we really want to care for the fungi that we're trying to cultivate, right? So these mushroom blocks, we actually have several of them that were purchased by GreenThumb, the mushroom blocks and the dowels. These are wooden dowels that are myceliated, and we're going to open these up after the workshop, and we're going to separate them out into smaller packages, and you guys are going to be able to come here to Smiling Hogshead Ranch and pick up 2 or 3 of these packages to take home and work with in your garden or in your home. We're going to show you a little bit later on where these are going to be stored at, and it's just going to kind of be an honor system where you can come indiscreetly and pick up, since we can't gather and have a bunch of people here at the same time. But this material is, it's not free. It's free to you guys because GreenThumb purchased all of it, but one of these blocks usually costs between 30 and 40 bucks. This is living material. They have to ship it overnight, so there's kind of a high shipping fee. So you end up paying $50 to $60 for one of these blocks, unless you work with someone to order a bunch of them at the same time. You can reduce your shipping costs. But you don't want to abuse these blocks. You just paid money, or someone has paid money for them, and you want to put them in good conditions. If I were to just break this block up and throw it down on this mulch here that's out here at the garden, the chances of it catching and actually inoculating the type of mushroom that we want to grow are very minimal. So through these processes of pasteurizing the wood chips or any of the substrate that we're going to be using today, this increases the chances of the mycelium that you've got, that you've purchased, that you've invested in, surviving and thriving and producing the fruiting mushrooms that you want, or producing the mycelium in the wood chips and in the ground that you want. There's lots of different ways, reasons to cultivate mushrooms. Today, primarily, we're talking about cultivating mushrooms for edible purposes. So a lot of these mushrooms are, all of them are edible, and some of them have more medicinal qualities, like this shiitake. So in the garden, we want to be careful because we all are New York City community gardeners, and we garden in the city, and we have to look at our soils and understand what's in them. We do that as we're growing crops, and we also need to recognize that mushrooms are a crop. So while they can work with the soil to decontaminate things, different varieties of mushrooms work with different contaminants in different ways. And I'm not going to try to explain all the different ways because, to be honest, us humans don't fully understand all those different ways. Mycology is a fairly young field of study in the environmental sciences, and we're still learning vast amounts about mushrooms every single day, week, and month. So as we move forward with our understandings, it's good to actually just work with the material and produce so that we can understand it in a different way. There's different ways of knowing. There's these scientific ways of knowing, and then there's just like working with things and understanding them because we understand their seasonality. We understand what they like. We watch them and make observations our own that informs our understanding of these things. So I usually have a presentation that we do, and I just want to share with you right now. I'm not on the thing. I'm just calling in with my voice on the phone. But if you guys wanted to see more of a presentation with some bigger breakdowns of different types of mushrooms and things like this, I suggest going to slideshare.com and searching for my name, Gil Lopez. And I have several slideshows that you can look at for free there and download if you want, and flip through. You can find the one on growing mushrooms at home. And that has a lot of the information that I'm going to be sharing today. And because it's such a compressed time frame, I'm probably going to be missing some of that stuff. I'm going to be going out of order. I'm trying to present a lot of information to you as quickly as possible. We're going to pause for just a moment. Yeah. Okay. So when we're working with mushrooms, we do want to try to keep a fairly clean working environment, and as well as our tools and our hands. We're outside in a garden. We're not in a clean lab, so we can only go so far with this. In the air around us, we have millions of spore. The thing that exists in the air the most are spore, where the mushrooms produce microscopic seed-like organisms or seed-like material that are not seeds because mushrooms are not plants, but spore float around and in the air. We breathe them all the time. They land on our skin, our eyes. They land on our food. We eat them. It's fine. It happens. They land on rotten wood out in the woods, and that's how mushrooms cultivate themselves naturally. What we're doing right now is we're mimicking a natural process, and we're trying to get the specific varieties that we want to grow into the optimal growing conditions. So what I'm going to do is I'm going to use some rubbing alcohol. I've just filled this little spray bottle with rubbing alcohol, and I'm going to spray my gloves here. And I'll probably do this a few times during this workshop. I would spray any tools that I'm working with as well. You know, we're using some scissors to cut up this cardboard box. So we want to try to maintain clean, bacteria, microbe-free surfaces for our tools and ourselves while we're doing this. Oh gosh, there's so much to cover. Mushrooms are generally separated into some large classes. We're talking about cat mushrooms today. These mushrooms usually have spore that are released from their gills underneath the caps. There's also mushrooms with pores that release mushrooms in a different way. There's the puff mushrooms that kind of explode and release the pores that way. There's lots of different types of mushrooms, and we're not going to go over all of them. I don't even think we have the human species hasn't figured out what they all are yet. So I will say that we are talking about mushrooms that primarily eat wood today. These are primary decomposers, and they're a little bit different than some of the mushrooms that live underground. So we have three broad groups of mushrooms that I'll just talk about very briefly. We have these Basidiomycetes, which are the club mushrooms, the cat mushrooms. A lot of them are wood eaters. And then these are the ones we're talking about today. But I also wanted to talk about these other types of mushrooms. There's the mycelial mushrooms that grow on the roots of plants. It's called Mycorrhizae. And these we don't often see as much. These are some Mycorrhizae tabs, which can be crushed up and put into watering can and just watered into your garden, especially good for plant starts when you have seeds. To get these Mycorrhizae, they have these positive associations with the roots of the plants, which means that they basically like create a sheath around the roots of the plants, and they extend the roots out. Plants don't have a digestive system. They rely on the fungi, bacteria, and invertebrates, or the FBI, in the living soil food web to digest material, nutrients, vitamins, minerals in the soil, to absorb water, and bring that to the root system in a bioavailable form. If you wrap the plant's root in a banana peel, it's not going to be very good. But if you decompose that banana peel with microbes and fungi and bacteria and invertebrates, then all the potassium and all the good stuff in that banana peel will become available for that root. So in this way, plants cannot digest their own food. They rely on the living soil food web. The living soil food web is the stomach, the digestive system of the plant world. Fungi are actually closer when we talk about evolutionary genetics to animals, humans. So because they have this ability to excrete enzymes into their surrounding and digest that food and grow into it, this is external digestion. And because they have that, many scientists believe that they're actually closer to the animal kingdom than to the plant kingdom, but they are a separate kingdom. The fungi kingdom includes bacteria, yeast, molds, and fungi, as well as some other organisms. Of course, the animal kingdom, we chew our food, we digest it internally, and it fills us in that way. But fungi are really important for the plant kingdom to break down all this matter. And these mycorrhizal mushrooms is also this powder that's a mycorrhizal powder. One popular mycorrhizal fruiting mushroom that we kind of know and love are the oh gosh, I'm blanking on the name. They're usually like truffles. Truffles are a mycorrhizal, and we haven't figured out good ways to cultivate these mycorrhizal mushrooms. In these tabs, we have some probably truffle mushroom powder inoculant, but there's no guarantee that we're going to grow that thing. Whereas when we grow, this is growing asexually mushrooms. When we reproduce this is Sawdust Spawn. And when we take this, and I'm going to show you a process of taking the Sawdust Spawn and mixing it with wood chips and more sawdust to create a box where we're going to reproduce and grow out that spawn to make more mushrooms. Because we could just take this, we could open this up from this little plastic bag here. We could cut little slices in here, and we could just let this fruit. This is ready to go. This would probably fruit in a few weeks if we just let it. But what we're going to be doing today is expanding this block so that we can get more fruit over time. And so the first thing that I'm going to do is I'm going to line this milk crate with some cardboard so that we can get this thing, we can fill this up with sawdust and mulch without it all falling through the cracks of the milk crate. So I've cut this cardboard to very specific dimensions here, and I think I have to give it one more cut before it's really ready to go. So we'll do this here. And this is just one way to do this. There's so many methods to this. I see people doing something similar to this in a laundry basket, a big wide one or tall one. People have used, I really actually enjoy using the fruit containers, which I have one of those, and I might show that too in a minute. Let's see if we can get this in the box though. Okay. So I did some work before this workshop started to try to get this kind of perfect, and I could have spent a little more time on it. But that's all right. We're doing pretty good here. It's a little smaller than it needs to be. We have an edge missing, but that essentially is going to be our container for these mycelium. And what I have to fill this with is actually, where's my, oh yeah. Okay, so we're going to be working with a pink oyster mushroom that, that we have here, and some sawdust. And I also have some wood chips that I've been soaking in water for about 10 days. So those,
Hey, Gail, we have two quick questions about the cardboard, but we're keeping all questions for Q&A, but just
Sure.
quickly, was the cardboard sterilized, and does the glue inside the cardboard not hurt the mushrooms or the soil?
Yeah, so the cardboard was not sterilized. You can sterilize it if you want, but generally cardboard is pretty clean. And let me see, so when you get a cardboard box, there's a stamp on it. I don't know. Oh, here, you can kind of see it here. There's a stamp on it, and it's going to say where it's from. And you want to get cardboard that's made in North America or Europe, but generally North America, because there's standards in North America that prohibit the certain glues that they use, especially in China, that can be harmful or detrimental to the fungi. So yes, that is a great question. You want to pay attention to where your cardboard is coming from. I'm not sterilizing it because cardboard is pretty sterile to begin with. And again, we're not working in a completely clean environment. So as we're working in the garden, we're taking some risks with possible contamination of other mushrooms or mold. It's something that I've learned to deal with, and it can affect negatively the outcome. You might get a little bit of mold here and there, but I find that it's usually not from cardboard. It's usually from some other thing that's gotten into the mix. So we have these things here, and I want to talk just a little bit about sterilization and pasteurization and the different methods to do that. So this method is called the cold anaerobic pasteurization. And what it does is when I put the wood chips in the water for like 10 days or 2 weeks, what happens is we create an anaerobic environment. The conditions for are not good for aerobic microorganisms, which if anybody is a composter here, you know the aerobic microorganisms need oxygen. That's why we turn our compost piles or we force oxygen into the piles. These aerobic microbes are very helpful in many situations. There aren't that many of them that are harmful to human health and safety. But with the anaerobic ones, the ones that thrive in conditions where there is no oxygen, is no air, such as underwater and in like boggy places. And we all know the smell of anaerobic conditions. We've evolved as humans to be repelled and repulsed by the anaerobic microbes and the smell of that, because a lot of them are harmful to us and our health and safety. So generally it's ill-advised to create anaerobic conditions in your garden or anything. But in this scenario, what we're doing is we're encouraging these anaerobic microbes. And when we dump out the water, we're going to expose all that wood chips to oxygen again. And those anaerobic microbes are going to die off. And they're going to be the first round of food when we introduce our mycelium. And then the mycelium is going to continue to grow on to the wood that is softened and ready to be eaten by the mycelium because it's been soaking for the past 2 weeks. So that's one way of pasteurizing or decontaminating wood chips. And it's one of the safest ways, and it takes a while, but it's really inexpensive. It just takes a watertight container, some mulch and water, and some time. Another way to do that, which we often demonstrate, is using hydrogen peroxide. Now, with this, you need to get a certain percentage of hydrogen peroxide diluted in your water. And oftentimes during these workshops, we'll use some straw and hydrogen peroxide. So we would take some basic straw that you can get in a bale and just fill a 5-gallon bucket with it, and then fill it up with water and put our hydrogen peroxide in there in the proper ratios. Now, some people have different ratios for this. Of course, the more hydrogen peroxide you use, the more likely it is to just kill everything more quickly. But generally, we put the straw and the water and the hydrogen peroxide in. I think we use about a half cup of hydrogen peroxide at about 60% hydrogen peroxide for a 5-gallon bucket of water. and we let that sit for 45 minutes to an hour so it can do its work. And we'll put like a stone or a block or something on top of that to push down the straw so it's all under the water, and you see the little bubbles fizzing up with the hydrogen peroxide. We're not going to do that today. Honestly, we had problems finding hydrogen peroxide, but that is a fairly straightforward technique in times where hydrogen peroxide isn't at such a high demand. Another way to do it, which I mentioned earlier, is the heat pasteurization. That's using a flame or heat to warm up the mulch in the water for a specific amount of time. If anybody has ever done canning or jarring, you're familiar with having to pasteurize your jars. You put them in like a pressure cooker, and you clean the jars. You make sure that they're all clean. It's basically the same concept, except for we're trying to get a bunch of mulch pasteurized, and we usually use a big 5-gallon drum to do it. We have to like dump it out and prepare space and do it in situ in the place that we're actually going to be using that mulch, because it's really hot and boiling water. When you dump it out, it's kind of like, it can be dangerous. We don't do this at our garden because we're not actually allowed to have fire here. We just have these things to demonstrate, and we go to other places and do that particular technique. But I really do suggest using this, just like 2-week-long pasteurization process. And when I teach this workshop, actually, in other places, what I like to suggest is people use coffee grinds from a cafe. So if you call up your local coffee shop and you ask them to save all their coffee grinds for the morning or whenever their heavy business hours are, then you can go there and pick them up, and you'll have basically like a whole, container full of coffee grinds. And because that morning all those grinds had hot water pass through them to percolate the coffee, what you have now is pasteurized coffee grinds that don't have any other spore, mold, and other stuff living on them. So you can take those directly when they're still fresh. I like to get them when they're still hot and let them cool. You don't want to add mycelium to hot substrate, but use those in this process that we're about to do. So I can also use the wood chips, and we're going to use sawdust. You can use cardboard that you just shred up or cut into pieces. You can use newspaper or packing materials like this, any kind of like forest product, right? Cardboard and paper are made of wood. The amazing thing about fungi and mushrooms is the ones that we're using, these decomposing saprophytic mushrooms. Saprophytes are the wood eaters, and they are actually one of the only things on the earth that can break down lignin, which is one of the strongest natural structures on earth. And it's made by trees to produce their wood and those strong trunks. So if it weren't for the fungi breaking down that lignin, we would actually just be piled up wall to wall, ears to ears of just tree trunks everywhere. So mushrooms really form a really important function in our ecosystems. There's lots of other functions that they perform. They act as a kind of intermediary between different plant species and whatnot underground, moving material, which gives information. I won't go too deep into it, but there are studies that show that fungi work with plants growing in a sunny field and plants growing in a dense shaded forest. The sunny field has lots of sun. The forest has lots of rich, deep humus soil, but not a lot of sunlight. So the fungi actually underground network of mycelium moves the photosynthesized sugars and carbohydrates from the field to the plants in the forest that don't have access to as much sun. And they move minerals and nutrients from that deep, rich soil from the forest out into the thinner soil areas into the field. So there's this exchange. And even plants excrete exudates into the soil, which attract microbes and fungi, and they can communicate things. When a plant is on fire, for example, it excretes certain exudates, and it tells the fungi network, I'm on fire, and it lets the nearby plants know, get as much water into your cellular structures as possible so you can fend off this fire. It's an real-time direct communication between plants that fungi facilitate in our forests, and we can learn a lot from them by studying them. So I'm excited about the research that's happening. That's not exactly what we're talking about today, but so I'm going to jump back into this a little bit. I have some sawdust. This is sawdust from woodworking shop. This is hardwood. There's no plywood, treated lumber, or anything in this batch of sawdust because we work with trusted woodworkers and they don't use any of that material, or if they do, they remove it from their from catching the sawdust. So we're going to use this combined with our wood chips that have been cold pasteurized anaerobically, and some of our mycelium here, our myceliated block. And you know what? This is a little bit of an old myceliated block. Would you pass me one of the, is there an oyster mushroom over there? Yeah, let's do this. Well, this one's the, yeah, this one. So we're going to be using, actually, this is rain spawn, and this is a lot different than sawdust spawn. So you can buy different types of mycelium to work with. The sawdust spawn is a little bit weaker. It doesn't provide as much nutrient to the mycelium that's growing. The grain spawn has either wheat or rye, berries, grains that actually have a lot of nutrients. You know, those are seeds that have a lot of nutrients that would support a cotyledon, a little seed that comes up, a little sprout that comes up and has to get that sunlight in order to turn into true leaves. But inside that seed, there's all that energy, and what we're doing is we're feeding that directly to the mycelium here. And this can go for a while because it has so much energy inside it. You'll get multiple fruits from this, and we're going to break this up and introduce it by layering, like a lasagna style, into this box with our sawdust and our wood chips. The first thing I'm going to have to do, though, is I'm going to have to dump out the wood chips so that we have no water in there. And I'm going to do that, and I think I'm just going to do it right into this box and let it drain out. And then I'm going to dump it back into the thing. So this is going to hydrate it's also going to hydrate the box a little bit, and it's going to get those microbes, those anaerobic microbes in here. And I'm going to pass this back into the bucket. Oh, that didn't drain as good as I wanted it to. That's how well I made the box fit in there. So I'm going to take that and put it back into our bucket here. I'll leave a little bit of that in the bottom. I'm going to make a hole down here so that that drains. We don't want the water to stand in this. This is actually a good exercise to see because, yeah, we don't want water to be standing down here. So I'm just poking a couple holes right now with my fingers, but I actually have a tool to do it. So I'm just going to get that tool here and poke some holes in there. And if it's not draining, that means it's probably not allowing oxygen into the sides. And these fungi, they actually breathe in oxygen and exhale carbon dioxide, just like us humans, different than the plants. So they need oxygen. So I'm going to poke some holes in this so that they have a little bit of a way to get that oxygen into the box. And this is going to help with the production of the mushroom later on. Now, ideally, these guys would start fruiting for you. And in order for them to fruit, there's going to be a few different conditions that you can kind of like force into their home. And as I continue to talk, I'm just going to start making this layer. We're going to use the sawdust, and we're going to use the mycelium right here. The myceliated block. and we're going to use our wood chips. So here's that block. I usually like to pass this around, let people smell it. I think it has kind of an almond smell. Of course, different mushrooms have different types of smells. Yeah, these are grain berries, and you can see all that white. You know, these are stuck together. This is the mycelium sticking them together like that. So I'm just going to kind of gently break them apart and sprinkle them around. And I like to do a ratio of about 1 to 5, 1 part mycelium to 5 parts substrate. Your substrate can be any food that we're feeding to the mycelium. We've talked about recently percolated coffee grinds. We talked about cardboard, paper. We're using sawdust and pasteurized wood chips. So these are all different substrates. The substrate is basically anything that we're feeding to the mycelium. The mycelium, the active living mycelium, we call spawn. And we can have grain spawn, which we're using today. We can have sawdust spawn, which is very similar to grain spawn, except for it's on sawdust instead of grain. Some people say that the sawdust spawn transfers to sawdust more easily because it already knows how to eat it. And that would be especially true if you're using sawdust spawn from an oak tree, and then you have sawdust, oak sawdust. Then the fungi actually already know how to break that oak down. So it's going to be more readily and quickly eating and establishing itself in its new environment because the food that it's eating is something that it's already used to digesting. Now, this is an interesting concept because right now I'm making this in this box with clean materials. I know that these aren't contaminated because I know the source of them. But in our gardens, sometimes we're not really sure, or we know for a fact that our soil is contaminated. So working with that, there is still a yet developing field of study in remediation, bioremediation, called mycorrhization, which I mentioned earlier. Bioremediation is the process of using biological agents to clean our environment. So using plants is called phytoremediation. Using microorganisms is called remediation. And using fungi and mushrooms is called mycorrhizal, M-Y-C-O remediation. And as I mentioned, this is still a budding field of inquiry and scientific discovery. But essentially, what we were finding out is that different fungi and mushrooms have different, to use an analogy that Trad Cotter used one time that I heard that I really like, they have different sets of keys. And if you can imagine a fungi who releases enzymes into its environment to digest its surroundings and grow into them and absorb the food that's around it, if you can imagine a fungi releasing a certain enzyme, and that enzyme acting as a key to unlock the proteins and nutrients in the sawdust nearby, the wood from the oak sawdust or the ash sawdust, then maybe maybe we have grain spawn like we do here, and it's used to breaking down rye berry grain or wheat grain. And then it's pumping out enzymes that break that grain down. It's like loving it. It's fine. It's happy. And then you take it and you introduce it like we're doing right now to a box full of wood chips and mixed sawdust. And suddenly the enzymes that these oyster mushrooms were producing to break down the grain aren't working anymore. They're like, whoa, hey, that's not doing the thing. We need food. So they start producing another enzyme. And if you think of these enzymes as keys, then different fungi can have different keys to unlock and break down different materials. Something like shiitake is pretty specific. It really likes oak. Oyster, on the other hand, has this wide variety. And if you think of their keychain versus the shiitake keychain, maybe the shiitake is walking around with like 3 or 4 keys on their keychain, and they can break down oak and maybe like 2 or 3 other varieties of trees, species. Whereas oyster, they'll break down any tree you throw at it, basically. And they also kind of enjoy toxic soils. They'll go in there and they'll break down formaldehyde and like different things. So as we study these and we start to understand the different keys that each one of these species has that it can access at its disposal, and how long it takes for them to pull out and figure out that key, and we can kind of train them in labs ahead of time. But this is a very interesting field that's happening right now to try and learn to deal with and decontaminate the environments, the post-industrial environments that we live in today as a society. So in that way, some people say that fungi can save the world, or that they're good allies for us in our environmental efforts, and that stepping up our work with them and understanding how to work with them and respecting the way that they work through that understanding is really good work for us to be doing as stewards of the land and our environments. So that's one reason that I really have enjoyed working with fungi over the past few years, is because very rewarding to keep on learning about different techniques, different varieties of mushrooms that like to grow in different areas. And I've actually been privileged to work with fungi in labs with some of the really formative thinkers that we read about and talk about, as well as some local bioartists and activists who are kind of like on the front lines here in New York City with this. And I would be remiss to not mention Jan Munn, who introduced me to this work way back when. She invited a bunch of folks with the Mycological Society of New York City here to this garden, and we inoculated a bunch of pink pearl oyster mushrooms like these into these long myco booms, which she used as an art installation at the Exxon Valdez, or the Exxon spill site in Greenpoint, which used to be National Oil. So we have our box. I'm going to cover it gently with a little bit of sawdust just to get the grain spawn on top so it's not exposed. And what I'm going to do here is I'm going to request one of our other members over there to grab me a black trash bag. And that'll come out in just a minute, and we're going to put this in the trash bag. This is essentially done for now. I'm going to add some water, and I'll add rainwater. It's important with mycelium, which is the budding state. We're propagating these mushroom right now, and with seedlings or seeds in general, to use water that comes from the rain or has at least been sitting out for a little while if it came from the tap. Because we put things in our water that kill microorganisms. And what we have here is a microorganism that we want to live and survive. So we want to make sure that we don't poison it right at the outset of its creation. So we'll be using some rainwater in a little while. And we might not have time for it during the workshop, but I will be adding water to this. What I'm going to do here is I'm going to just take this black contractor bag, and I'm going to put the whole thing right inside of it. And this is going to create two things. It's going to create a humidity tint, which we really want, because the fungi really like high humidity. They will dry out very easily. It's also going to block out the sunlight. So we'll probably want to store this, because we're in the warm season, in a cool, dark place where it's not going to dry out. In the cold season, we want to put it in somewhere that's a little bit warmer. If we have a radiator in our apartment, we can put it by the radiator. And I'm going to do the same thing I did to the box earlier. I'm going to poke some holes in this plastic bag. Because while we want to retain the moisture in here, we want some air exchange. We need oxygen to come in and carbon dioxide to get out. So I'm just going to poke large amount of holes in this bag. And just to make sure that we have plenty of air exchange. And basically, I'm going to label this. We use which mushrooms did we use? We used the oyster mushrooms today, but Ploetris osteratus, the oyster mushroom spawn, and the grain spawn. I'm just actually going to leave this in here for now so I can reference it a little bit later. I'll put the date that we inoculated and did this build so that we know, how long it's been there. And then a little bit later, I'm going to come back at a fairly regular intervals. And when this is all closed up, I'm going to come and check on this probably every week or so for the first month. And then I might go to every other week for the second month, and then just like every once in a while for the third month. But essentially I'm going to open it. And when I open this one on my mushroom check, what I'm going to be looking for is condensation all around the inside of this bag. If there's not water dripping and condensating on this bag, on the interior, then we're too dry and we want to add more moisture. I would start just with a cup or two of water. I'd open it up. I'd look, you don't want to touch it too much. You don't want to breathe on it too much. Of course, again, we're outside, so we're not in a clean lab environment. So it's not going to be 100% clean, but we don't want to get over here and start poking around or anything. If we do, we definitely want to go ahead and use our, use a little bit of peroxide or alcohol again. And want to be clean. So you can kind of look in there, poke around like you would a plant before you water it. You want to look and see if it's moist. And if it is, you're good to go. You can leave it just like that. But if it needs water, again, gather some rainwater or some water that you've let kind of like chill out overnight and air out. Put that in there and then wrap it up and put it back in its dark corner. I want to show you, so this one's done. I want to show you guys, because we're almost out of time here, one of these that I did in the past. And so I created this mushroom box last fall at the Queen's Library during a workshop. And I actually used a vegetable crate that I found at, the vegetable stand. And you can see the mycelium growing on the edges. When I harvested this, the mushroom was growing from the bottom. I had it on a baker's rack, and there was a big mushroom growing off the bottom here. I harvested that. There was some mushrooms growing on the side. And honestly, when I did that first harvest, I just kind of put it outside. I shoved it in an out-of-way location, and we could probably get another harvest off this. Or after I got my first flush and I had a few really good meals, I probably got like 4 pounds of mushrooms off of that, which was amazing. And now what I have is this big block. If you look at this, this is like maybe 4 times the volume of the size of the block that I used to start this, which was the same process that I just ran through with you guys. So in about 3 or 4 months, you're going to have something like this after with the one that we just created. And like I said, I already got a really good harvest. And what I can do now is actually take a chunk of this and I can give it to my friend and they can create a whole nother box or 2 with this. And I can do that again, create another box with that one. And then with this one, it's got a little bit of mold on it. So I would just take that off. And because we've already, got our goodie out of this, I would go ahead and experiment with this. There's still a little bit of mold on it, but mold exists right alongside fungi in the environment. So the mold actually, it could outcompete and you could end up with a box of mold, but I already know that this was strong mushroom material and it fruited already. So this mold is really kind of not inconsequential. I could actually redo this whole box, use this and break it up and use this as the inoculant to expand this box again and again and again and keep on expanding out. I could make, you know, with what I had here, I could make 4 of these boxes and give a few away for friends. And then in 3 months, I could do the same process again. I could harvest some mushrooms. I can expand into 3 or 4 boxes and just repeat this process. It's like making plants, starting seeds, propagation. It's the same kind of idea. So I think we're running out of time. So I'm just going to go over one more interesting thing before we go into a question and answer session. So keep your questions. I'm sure you're writing them in the comments there. We got them. But I wanted to talk about parasitic fungi for a little while because they're also really fun to think about and talk about. Some of you guys are familiar. We talked about the mycorrhizal mushrooms and the beneficial relationships that they have with the roots of plants. And these are always beneficial relationships. We also have the wood-eating mushrooms, the saprophytic mushrooms, primary decomposers and secondary decomposers. These oyster mushrooms break down wood directly. And we have other stuff like very popular is the button or portobello mushrooms. They actually grow on kind of finished material. They grow on composted material. They won't grow on a fresh log. So they're not the saprophytes, but they're also good to eat. And then we have these parasitic fungi. And some of them that you might know is like corn smut, very popular in Mexico. It's a fungus that attacks corn. And it's parasitic because it actually decimates the seed. You can't grow the seed of corn once it's been attacked by corn smut. But it's good in a way because it's actually a delicacy and farmers can charge extra money. It's like an added value agricultural product. There's also not so nice parasitic fungi like foot fungus, which is a fungi that inhabits the human epidermal, our skin, and creates an itchy rash nobody really likes, terrible. There's also like cedar apple rust, which is a fungi that can have negative impacts for trees. And there's several other interesting ones that we could talk about, but I am aware that we're done on time and I want to respect that and move into questions and answers. I'm hoping that y'all have some for me.
Oh my God, do we? Thank you, Gil. That was really great. That was so much information packed into a short time frame. So we really appreciate everything you're doing and everything that you've taught us today. So we had a number of questions about the wood chips. Where are you getting them? Is there a preferred type of wood chip? Is cedar an issue due to its antifungal properties? And did you pasteurize the sawdust?
Yes, okay. So I did not pasteurize the sawdust. The thing about, okay, here's the thing with wood, using wood. Ideally, you have a tree that has been felled, like not actively growing for 3 weeks to 3 months. Like after it's cut down, 3 weeks after that, a lot of the antifungal properties that exist primarily in the cambium and bark layer of the trees, that begins to subside after 3 weeks of that tree being cut. Now, after 3 months of that tree being out in the forest, cut and out in the forest, it gives more time for other fungi and spore and bacteria and mold and stuff to get into that tree. But it has to attack it through the outside. So after 3 months, it's advisable to find something a little fresher. So that window, 3 weeks to 3 months is the one I like to try to work with. Of course, you don't always know where your tree is from, especially in our urban environments. You know, you're not harvesting it from your land. You're just trusting probably a tree worker, a arborist that works for a tree service company. That's where we got the big chips that we have. We also have some smaller chips that we got from the Parks Department. We have a big garden. We're lucky to have a place big enough for the Parks Department to come and dump like an 8 to 10 yard load of mulch, which is what they usually need. The same thing for Greenwood Cemetery is a great place. They have an amazing silviculture practice where they're actively managing their urban canopy or their urban forest there at the cemetery. So they're often cutting down diseased, old, sick trees and chipping them. And they love to give them to community groups. In Brooklyn, they kind of don't like to travel outside of Brooklyn too much. But they also have a very yard truck, and they need a place to dump like 8 to 12 yards at once. The sawdust, when we have sawdust in its original form, which is a log, the only place that the other fungi and mold and stuff can get in it is the outside of the log. Unless it's dimensional lumber, then it's still the outside of the log. And the surface area is pretty small compared to the surface area of sawdust. But when you cut that, that wood, you're essentially taking that window, that 3 weeks to 3 months window, and you're opening it. But you've already had the tree down for a little while, and you know that you're not making like high quality hardwood furniture out of rotten wood already. So the wood it's not already having fungi on it. So sawdust is really usually pretty good to use straight from the woodworker's place. And there's lots of woodworkers all around New York City. Go on the web and search woodworker and give them a call and see if they have some extra sawdust that you can use. But generally, unless you store it outside or it gets wet and moldy and stuff, the sawdust is really good to use straight. You don't have to pasteurize it. I think that answered both of those questions.
Yes, thank you. Relatedly, are there certain mushrooms that are better for beginners, and are other varieties like more picky about what their substrate is?
Yes. So oyster mushroom, I always recommend oyster mushroom. I love working with oyster mushroom. There's lots of different kinds. There's the pink oyster, which is tropical, so it's not going to come back year after year, especially if you keep it outside in our cold weather. There's gray oysters. There's the phoenix oyster. There's all sorts of really interesting oyster mushrooms to work with, and they're really easy. They like lots of different types of wood. They're very flexible when it comes to working in the garden. They will eat coffee grinds. They'll eat the sawdust and the cardboard and the paper. And I just actually remembered because some of that question was like some mushrooms that are more picky. And the last question actually asked about a sapwood. The mushrooms generally, this is a broad strokes kind of statement, but they generally prefer hardwood trees. They don't enjoy as much trees that have sap, like pine and cedar and really the evergreens. Some of the mushrooms will tolerate eating them, but generally you want to try to find hardwood to work with. And then you can find, I mean, the library has some really good books, the different library systems that you can check out. You can download little things online. This one, I love Peter McCoy and his Radical Mycology. This is a little zine that you can download. And it has in here kind of like, it has several pages where it lists specific types of mushrooms, and it tells what their growing patterns are. It tells what types of wood they like. It tells the temperature, the ideal temperatures and humidity levels of these things. So getting to know what types of mushrooms you want, if you want a mushroom to eat, doing a little research and figure out which one. If you want a mushroom that you can make a tea with and it's going to help you medicinally somehow, doing research and figuring out what you want. Now, some of these, and I apologize, I really didn't have that much time to talk about it, but with these wooden logs or with these wooden dowels, what we do with these is actually we get a log, a whole log, and we drill holes at a very specific diameter that these things fit in. And then we tap them in with a little mallet, and then we use some wax. And we have some wax from previous years, this melting wax that we have this can that we've been melting the wax in, and we have these paint brushes that are, just always ruined, but we put the wax on top of the hole after we drill it so nothing else gets into that hole. We're going to be giving some of these away. And we have this year this plug wax that's actually spreadable with your finger. So we're going to cut these up into smaller portions, and we're going to have these available for you guys. And maybe now is a good time to show people where we're going to be having some of those things.
Yeah, that sounds good.
Okay. So I wasn't going to have Mia show you all this, but she's not mic'd up. So I'm going to show you guys. But we have lots of mycelium over here in these different bags and blocks. You know, we have like different blocks of mycelium. We're going to be putting these in smaller little sandwich bags for you guys, labeling them with what type of mycelium is in there. And we're going to put them in this, this is called a job box or a game box. And this one is not locked. This is at the perimeter of our property, right here at the corner of Skillman Avenue and Davis Court. I'm sorry, Pearson Place is the name of this street. And we're gonna have the mushroom material in here separated out for you guys as participants of this workshop who have registered and participating to come pick up 2 or 3 different packages. And that'll be at, you know, your discretion, and it's kind of just gonna be an honor system. So don't take them all, share with everybody else. We're happy to share, and we hope that everybody can get what they want. So we have some shiitake. I'll read some of the mushrooms that we're going to be, that Mara and GreenThumb have provided for all of you guys to take home. We have shiitake, we have agaricus, which is, I believe, garden giant, and we have more oyster mushrooms. Those are the grain spawns. And we have so many more wine caps. And then we have gray dove oyster mushroom. These are the plugs. And we have some reishi plugs. So we're going to be separating those out for you guys a little bit later on. We have some labels there. What else? Any other questions?
Yeah, we have a few.
Superb.
How
Love
long
it.
will the mushroom material last while they after they pick it up?
Right. Okay. Good question. So when you mix them with sawdust or coffee grinds, it takes like 2 or 3 months in the summertime, maybe 3 or 4 months in the wintertime. So it depends is the answer, but it depends on the type of mycelium or mushrooms that you're using, the material that you're growing them on, and the temperature, humidity levels that you have them in, as well as the moisture. But generally speaking, when you use sawdust or coffee grinds, there's lots of surface area for the fungi to get into, and depending on the amount of material that you use at the beginning, like I said, I like to suggest 5 to 1, 5 parts of the spawn. So I'm sorry, 1 part of the spawn to 5 parts of the substrate. But if you use more, it's going to be faster. If you use less, it's going to be slower. If you use sawdust and coffee grinds, it's going to be faster. If you use wood chips, it's less surface area. It's going to take a little longer. If you use logs, it's going to take a lot longer. So sawdust, 2 to 3 months in warm season. Wood chips, 3 to 4 months in wood season, maybe 5, depending if they're really big chunk wood chips. And a log is going to take you a whole year to a year and a half before it actually produces a fruit, because it has a lot less surface area and a lot more work for the mycelium to actually do. Now you can decrease that time by adding a lot more plugs into the one log so that you have more mycelium working on the log at one time. But generally, 3 to 4 months for something like this, and a year to a year and a half in our temperate environment here in New York to get a log to start fruiting. And that's, you know, having access to water and warmth in the winter and cool in the summer, so it has good conditions. But I should talk about fruiting just a little bit. So when something like this starts to grow, when you see mycelium covering your substrate, and you know, this used to be sawdust and a bunch of things, and now it's just breaking off in blocks. And when you see all this white stuff forming on the edges, you'll see what's called primordia. And the primordia, there's none here right now, but it really looks like little pins, like you know, the push pins with a little round top. It looks like that pinning off of this mycelium. And when that primordia starts to develop, you're going to notice it. You're going to open your bag to check the moisture, and you're going to be like, oh, there's little things sticking up. That's when you want to take your bag and you want to put it in indirect sunlight. You can open it up, get it some good fresh air. I like to give it a heavy drink of water at that point, and put it in indirect sunlight, which means if you have a window with light streaming in, you can put it underneath the window. The light's going to bounce off your wall, and that's indirect sunlight. You don't want it in the window. You don't want the sun on the box. You want it indirect ambient light. And when you have that, it's actually going to increase the nutritional content of the mushrooms as they fruit, and it's going to help induce the fruiting to happen more prolifically. So it's a good thing to do. You can also, if you really want to kind of force it, kind of like give it a good soak and then just like drop it. And that shock will send a message to the mycelium. So the mycelium go to fruit whenever they're scared for their lives, really. They're either going to run out of food inside the box and they're going to be like, we're hungry. It's time for us to reproduce. We need to make a fruiting body and allow our spores to go get some more food. Or if it gets too hot, they're like, oh, we got to get out of this environment, put up some fruit spores. If it gets too humid or too dry, you know, all these conditions. And whenever there's a shock to the system, that kind of confuses them and they're like, whoa, we don't know what's happening. It's time to fruit. Get our spores out of there. So those are some different ways to kind of encourage or force fruiting.
Thank you. That was really helpful. Very cool. There's a lot of information in here, and still a few more questions. Can you briefly address people who are going to be growing inside instead of outside? Are there some varieties that just will not work inside? And is there a concern for mold spreading to the walls of your house?
Varieties that won't work inside. I would say there probably are some that are more problematic, but if you're really dedicated, you can make it work. You know, I know one guy who has spit out a whole like humidity closet. He took a closet in his home and put plastic around it and made it to where he could control the temperature and humidity inside that closet. And he can grow whatever mushrooms he wants because he has a really controlled environment. He doesn't have to worry about mold on his walls because he's outfitted the walls with moisture protection barrier, which also helped him to control the humidity. Now, of course, you know, if you're overspraying your mushrooms and you get moisture on your walls, then yeah, you should worry about mold. But generally, you know, if you have them inside, you have them contained in your bag, you know, and when you water your fungi, you open your bag and you're just like watering inside your bag and not getting a big mess everywhere. Yeah, we have a few holes, but that's just going to allow a little humidity to escape. It's not going to allow water to just seep out, and you don't want that much water in here anyway. So I generally wouldn't worry too much about cultivating mushrooms in your house, having an effective mold on your walls. But one thing that you do want to be careful of is you just want to know that when the mushrooms do go into fruit, they're going to release a lot of spore. These spores are microscopic, but there's lots of it. If you look at a fungi, at a mushroom, if you look at the ground nearby it, you might see some discoloration. It might be a little white, it might be a little gray or brown. That often is just like a massing of those spores that have just landed right there. Some people have an allergic reaction to these spores, and when they're so prolific in our rooms, in our indoor environments, that could have a negative effect on our respiratory, or especially if we're allergic to them, we could have some sort of reaction. So you have to be careful whenever they're in the active fruiting phase to, you know, maybe have them near a window with the window open, or maybe even take them outside during that fruiting phase so they can let their spore go all over the place and not be in your home. But that's just something to think about whenever you're growing fungi.
Thank you. I'm going to combine a couple of questions into one final question, and the rest we're going to compile and send to you in an email, if that's okay, Gil.
Okay.
So there have been a couple of questions about substrate. Can dead leaves be substituted for the sawdust or wood chips? Would you ever want to mix substrates? There was a question about having coffee and wood chips.
Yeah. I generally don't use leaves unless you're using a fungi species that needs partially decomposed material. As I was mentioning earlier, like the popular portobello. I don't cultivate that one because it does require this decomposed material at the outset, and it's just a little bit more complicated. But if you were growing like these types of secondary decomposers, as they're known, using leaves is a really great way to get that going, especially like partially decomposed leaf mold. I think leaves could be used. The problem with leaves is that they're going to bring a lot of contaminants, so you're definitely going to want to pasteurize them using either the heat pasteurization, the anaerobic cold sterilization, or the hydrogen peroxide method. And there might be some other methods. The Mycological Society of the United States has some actually one page of pasteurization where it lists several different methods. I think they have 2 or 3 that I didn't list that I've never used before and not really comfortable teaching about, but there are other ways to do that as well. The other part of that was, leaves and mixing substrates. So we actually mixed substrates here in the one that we created today. I didn't go to a process of like actually tossing it all together, but we did layer in the sawdust. I had the wood chips that I had cold pasteurized, and we had the mycelium. So we did use the 2 different substrates, and they work perfectly fine together. I like to mix different things. I think that you have stronger, more robust, nutrient-dense mushrooms whenever you mix different substrates. So I'm a huge proponent of putting the coffee grinds and the sawdust and the wood chips and the cardboard and whatever else you think that the mycelium might like. I like to even throw in, like, I wouldn't use this one because it's an old piece of wood, but like a fresh piece of kind of fresh 3-week-old wood, put some branches in there, and then you can do what you can use that to kind of just like bury in the landscape somewhere and start spreading the mycelium that way. And which brings us to what this concept of the mother patch, which we have over here. We've inoculated like a big pile of wood chips with fungi when we got it, and now the fungi is growing throughout the wood chips. And whenever we go and dig and take that wood chip and spread it around the base of our fruit trees, we're inoculating because we, months ago, whenever we got that wood chips, we've already put the magic in the potion, I guess, as it were.
And that's our time. Thank you so much, Gil. This was incredible. We really appreciate you. To everyone tuning in, thank you so much for joining us. We have a lot coming up in the coming weeks. Next week, we are partnering with the UN on their World Environment Day. So we're looking forward to a citizen science webinar on Wednesday about using iNaturalist as part of the NYC EcoFlora project. Friday, we're doing a climate resiliency panel that was rescheduled from the GreenThumb Grow Together conference. Very excited. We hope to see you on future webinars. Thanks everyone for tuning in.
Bye, everybody.